Today we're going to discuss about review for Unit 2 Assessment, Algebra 1, entitled Equations and Inequalities. Question number 1. The following is a student's solution to the equation. And so there are two steps mathematical errors in this work. Identify what steps each mathematical error occurred and explain why it is mathematically incorrect. So as you can see, I have pre-answered all these, so I will just be able to explain it to you like real quick. So let us look at step number 1. So 2 over 5 times 10x is 4x. 2 over 5 times 5 is supposed to be a 2 because this 5 and this 5 right here will cancel out and become a 1. So that should be a 2 times a 1, which is a 2. So this is an error. So let's keep on going. So minus 2 is copied down, equal is copied down, 7 minus. Let's take a look at this. 2 times 3 out of 2 is negative 3. So that is correct. Negative 2 times positive 3x is supposed to be a negative 6x. So that is an error. So we're going to answer here that the error occurred from line 1 going to line 2. And these are the errors. 2/5 was not distributed to positive 5. And then the negative 2 times positive 3x should be a negative 6x and not a positive 6x. All right, so we're now on step 3. Let's take a look at what error occurred here. So 4x plus 3x equals 4x plus 6x, and I see that the x went to the left side, so I assume that this was moved to the left side, which is minus 6 on both sides. Let's take a look at the answer here. So what happened was there was a negative 6x that was done here, and whatever you do there, you do on this side. So now this cancels out and becomes a 0. They are inverses. And so now this is supposed to turn into a negative 2x. And then you bring down the positive 3 equals a 4. And then you bring the 3 to the other side, or you do the inverse of negative 3, subtract 3 on both sides, making this become a 0. And this is a negative sorry, this is a positive 1. So let's take a look at that. So that is, if it became a 10x here, then that's an error because it's supposed to be a negative 2x. So therefore, when you want to bring the 6x to the left side, you must subtract 6x on both sides. So I explained that already. And then this should be, final here should be a negative 2x equals 1, which as you can see here, you have been given a positive 10x. So that's an error. So let's take a look here. So the error occurred from line 3 to line 4 with this reason. All right, so for letter B, it says here that solve the equation correctly. So I have copied all the equation here, and 2/5 times 10x is equal to 4x. 2/5 times 5 is equals positive 2 is equal to positive 2. Copy down negative 2 equals 7, and then negative 2 times 3 out of 2 is a negative 3, and then negative 2 times 3x is negative 6x. And then if our purpose is to put the x's on the left side, then you're going to add 6x on both sides. This now becomes 10x, and this one becomes a 0. 2 minus 2 is a 0. And then you will have 7 minus 3 is a 4, and then that is already a 0 right there. You cancel it out. Now, so you have 10x equals 4, divided both by 10, and this now, your x is 4 tenths, or 2/5, or zero point 0.4. Before we go into the next question, I just want you to keep in mind this equation because we're going to use it for our next question. Okay, next question. What does the solution to the equation tells us about the original equation? Well, it tells us that there is one solution because your lines intersect at one point. So what do I mean by lines? So these are the this is the equation, and we're going to plug this in as one line on Desmos. We're going to plug this in as another line on Desmos. And as you can see here, I represented this line as the green line, and then this one is our red line. So this is the point of intersection. We're going to get the x of that coordinate, and that is our solution. So let's have a real quick review on how to do this by hand. So our steps are First step is to start with the y-intercept and then identify your slope and do the rise over run. So as you can see here, for the first line, your y-intercept is at 0 and your slope is 4. You're going to do that to where it shows the rise over run, which is 4 over 1. And since it's positive, your positive 4 over positive 1 will be shown here, and also negative 4 over negative 1. Understand that if this is a positive number, then your signs are supposed to be the same. So you were going to do both here. So it starts with the y-intercept of 0, and I rise 4, and I run 1. So this is the positive over positive, and this is the negative over the negative 4 over negative 1. You connect all dots, and that is your line represented by x 4x plus 0. Then let's take a look at this one. So this one is your y-intercept right here, and this one is your slope. It's a negative 6. Because it is a negative 6, then your representation would be different signs for the numerator and the denominator. So negative means the signs are different. So this will be 6 over 1, and that is an by the way, this is a 6, and you know that the denominator of any whole number is a 1. So therefore, this is a 6 over 1. I just wanted to explain that. So let's go back to here. So one possible way is positive 6 over negative 1, and the other one is negative 6 over positive 1. We're going to do both. Again, please concentrate on your red line. So we start with our y-intercept, which is a 4. We do the rise of 6, positive 6, and the run of negative 1. So that's movement to the left of 1. And on here, we are going again, starting with your y-intercept of 4. Your rise is negative 6, which means you're going to go down 6 steps. And your run is positive 1, which is positive 1 unit to the right. Connect the dots, and those are your lines. If we are going to show this on Desmos, this is how it looks like. Plug them both as separate lines, and there you go. The answer is zero point 0.4, which is your solution. Question number 2. For the following problems, refer to the system of equations below. You will determine possible values for A and B to make each statement true. Statement number 1. Choose A and B to create a system of equation that has one solution, then sketch the graph below. Now, please understand that your A represents a slope, and then your B represents the y-intercept. So your slope here is 3/4, and your y-intercept is a negative 5. You want to create an equation that's going to have one solution to this line right here, which means that whatever equation you make must intersect this line. And the way that we will make it intersect is just by looking at the slope. We need to make sure that one solution means that the lines will intersect, and therefore the slopes must be different. So the y-intercept may or may not be different. And in this case, what I made was an A of equal to 2 and a B of 1. When you plug this in on Desmos, they are going to intersect at this point. Once again, this line right here represents what I created, which is the 2x plus 1. And this is your original line, which is y equals 3/4 x minus 5. Once again, your purpose here is to create a line where they will intersect at one point. They will only intersect at one point if the slopes are different. Next, letter B. Choose A and B to create a system of equation that has infinite number of solutions and sketch the graph below. This means that they will intersect forever, meaning to say that the lines are on top of each other. So therefore, if your original line is y equals 3/4 x minus 5, then you should create another line that's exactly the same, which is what I did here. Notice, I don't know if you can see it, but my red line is on top of my blue line, and that's vice versa. Therefore, the lines, all these intersection points of the two lines are considered as solution. Therefore, there are infinitely many solutions if the lines are on top of each other, which means the same exact line. Let us now go to letter C, and it says here, create a system of equation where A and B will have no solution, and this will only happen if your graphs don't intersect. They will not intersect if the lines are parallel. So how do you create parallel lines? It is when the slopes are the same, but the y-intercepts are different. So therefore, I created this line, y equals 3/4 x plus 2, which is parallel to y equals 3/4 x minus 5. Question number 3. Alexandra went to an amusement park She brought $80 to spend on her two favorite games. Her ultimate favorite game is the bumper cars, which cost $12 per round. Her second favorite game is the big fish, which cost $8 per round. Question A. Can she afford to play 5 rounds of the bumper cars and 4 rounds of the big fish? Justify your answer. So this is just clear cut, simple math. $12 times 5 rounds and $8 times 4 rounds is impossible because it will amount to more than $80, which is a money she does not have. So it will cost $92. So no, she does not have enough money. So let's go to question B. There are many possible combinations of bumper car rides and big fish game that will keep Alexandra within her budget. Represent the possibilities graphically, and we are going to use Desmos on this. All right, so I want you to understand that all these inside this shaded area or here along the line are possible solution combinations. We have said that the X is the bumper cars and Y will be the big fish. Understand that the negative side is not possible here because you cannot play negative times for the games. Also understand that they are just the whole numbers because you cannot play a fractional times when we're talking about games. So just all the exact whole numbers within this shaded area and along the line. All right, next question. Suppose she doesn't want to play either game more than 5 times because it stops being fun at that point. Show graphically how this will change the possible combinations. Let us use Desmos for this. Okay, so I need you to concentrate fully on how this will be analyzed, okay? Your possible combinations are just within this pentagon right here. It's where the three colors meet because there are already restrictions we have applied. We said that the bumper cars cannot be played more than 5 times, so it's x less than or equal to 5, as well as the big fish. So therefore, it's just this area right here. So once again, cannot do decimals, okay, and cannot do the negative sides as well. So just here, right here. All right, so I indicated here that all whole numbers on the shaded area and along the edge are possible solutions. So let's already answer letter D. Letter D says, suppose she wants to spend all of her $80 exactly, no change, no leftover. So assuming she wants to keep the constraint by not playing the game more than 5 times, is this possible? It is. Looking at Desmos, there is a point along the edge. By the way, along the edge is when you're going to spend exactly $80. That's the same as this one. So along this one is the exact $80. Within the shaded area, you will have some change. Okay, so here let's go back to question D. The exact amount is found on the edge of the graph. That's 4 rounds of bumper cars and 4 rounds of big fish. And the way to do the checking is by just multiplying them. So $12 times 4 rounds is 48. Uh, for 4 rounds of big fish, which is $8, is amounting to 32. So $48 plus 32 is exactly $80. I hope you learned a lot today and good luck on your test.